Hello everyone, myself J. Vinay Kumar, lecturer in Triple E. Today we are going to discuss about the subject Basic Electrical Engineering, which is a part of C18 curriculum. In the previous classes, we have discussed about what is a resistance. I think what resistance is the property of a substance which opposes the free flow of electrons. In a similar fashion, have also discussed about the electric circuit and the various parts in the electric circuit. So we have already seen the Ohm's law. It's nothing but at constant temperature, the current flowing through a conductor is directly proportional to the voltage applied. So if we remove the proportionality constant, we get I is equal to V by R. Okay, in this presentation, we are going to learn about the limitations of Ohm's law, and also we will be solving some problems on Ohm's law. Now let us see the first topic, that is the limitations of Ohm's law. Can you think of limitations of Ohm's law? Yes, Ohm's law has the following limitations. This law is not applicable to non-linear devices. Non-linear devices means they are vacuum tubes, gas filled tubes, and also thermionic devices. All this come into the non-linear devices category. And its Ohm's law is also not applicable where the temperature is not maintained constant. Okay, in the Ohm's law itself says that at constant temperature, the current flowing through the conductor is directly proportional to the potential difference applied across the two ends of the conductor. So, where the temperature is not constant, then the Ohm's law will not be applicable there. And this Ohm's law is also not applicable to non-metallic conductors. And it is also not applicable where gases are liberated on the electrodes. For example, electrolytes. In electrolytes, this Ohm's law is not applicable. And also, this Ohm's law is not applicable to arc devices like arc furnaces and also in arc lamps. These are the arc furnace. In this, the Ohm's law is not applicable. And the Ohm's law is not applicable to semi-conducting devices which are known to be non-linear devices. Okay, it's not applicable to semiconducting devices like germanium, silicon. Okay, in those materials also, this Ohm's law is not applicable. And this law cannot be applied directly to the AC circuits. Okay, these are the limitations of Ohm's law. Now let us see some problems on Ohm's law. The first problem is how much current flows through a 50 ohm resistance when a potential difference of 12 volts is applied across its terminals. Okay, in this we have to find the current, and the resistance is given as 50 ohms, and the potential difference is 12 volts. You can see here the given data is, first of all, resistance is 50 ohms, and the potential difference V is equal to 12 volts, and we have to find the current flowing through its terminals. Okay, we know that uh, from the Ohm's law V is equal to IR, we can find the current. You can see the circuit diagram here. Here the source is a 12 volt battery. Across that, a resistance of 50 ohms is connected, and we have to find the current I. So here the formula required is I is equal to V by R. It is nothing but it is the Ohm's law. Here we know the value for V, and also we know the value of R. If we substitute those values, then we get I is equal to 12 by 50. So on solving that, we get the answer as 0.24 amperes. Means 0.24 amperes is the current flowing in this circuit. This is the answer. Now let us see the next problem. Second problem. Determine the voltage to be applied across a 40 ohms resistor so as to make a current of 5 ampere flows through it. Before solving, we should read the question twice and we should find what is the given data and what he is asking. Okay, here in this problem, the given data is the resistance R is equal to 40 ohms. The current I is equal to 5 amperes. And we have to find the voltage. V is equal to how much? We have to find that. If we draw the circuit, it will be like this. A single voltage source. The resistance is connected across it. The value for resistance is given as 40 ohms. The current flowing through the source is 5 amperes. Here we have to find the voltage V. Here we know that the formula from Ohm's law, I is equal to V by R. It can also be written as V is equal to I into R. If we substitute the value of I and R in the above formula, we get as 50 into 40, which is equal to 200 volts. Okay, here the voltage applied across this resistance is 200 volts. It is the answer. Okay, now let us see the next problem. Third one. A resistance of 10 ohms is connected across a supply of 100 volts which varies in steps of 10 volts from 0 to 100 volts. Calculate the corresponding current for each step of voltage and also draw the graph by assuming voltage on x-axis and current on y-axis. Okay. In this problem, the given data is that the resistance is given as R is equal to 10 ohms, and here the voltage varies from 0 to 100 volts in steps of 10 volt, and we have to find the current at corresponding steps. Means at each step we have to find the current. Now let us draw the circuit diagram for the above question. The circuit will be like this. Here the given resistance is 10 ohms. The voltage is applied from 0 to 100 volts in steps. Okay, and the formula required to solve this is I is equal to V by R, where I is the current, V is the voltage, and R is the resistance. Now applying Ohm's law, we know that the Ohm's law is nothing but I is equal to V by R. Let us draw a graph. In this graph, x-axis represents the voltage in steps, and the y-axis represents the current flowing in the circuit. Now initially when the voltage is 0, the resistance is 10. It will be fixed, the resistance will be fixed to 10 ohms. So if we substitute those values, we get the value of current as 0. Okay, the 0 point will be there. After that, if we increase the voltage to 10 volts, then the current will be I is equal to 10 by 10, that is nothing but 1 ampere. If you plot that, it will be at this point. Now afterwards, again if we increase the voltage to the next step, that is 20 volts, then the current I is equal to V by R, nothing but V is 20 and R is 10. So 20 by 10 is 2 amperes. If we plot the 2 amperes on the graph, we get the point here. Again, we have increased the voltage to 30 volts. Then the current I is equal to 30 by 10, which is equal to 3. If we plot that 3 on the graph, we get the point here. And next, in the similar fashion, we have increased the voltage to 40 volts. Then we get the current I is equal to 40 by 10, which is nothing but it is 4 amperes. If we plot that point on the graph, we get here. And same fashion, we have increased the voltage from 40 volts to 50 volts. Then we get the current as 5 amperes. And if we plot that on the graph, we get the point here. A similar fashion, again we have increased it to 60 volts. Then we got the current, that is the current flowing in the circuit will be 6 amperes. And if we plot that, we get the point here. Again 70 volts, for 70 volts the current flowing through the circuit is 7 amperes, and the plotted point will be here. Again we have increased it to 80 volts, then the current will be 8 amperes. And if we plot the point, then we get here. Again in the similar fashion, we have increased the voltage from 80 to 90 volts, then the current flowing in the circuit will be 9 amperes, and the point will be here. And the last one, that is, if we increase it to 100 volts, then the current flowing through the circuit will be 10 amperes. The point will be here. This is the graph. If we plot the voltage versus current, then we get the graph in this fashion. Okay. Now let us see the next problem. That is the fourth problem. A source of EMF is equal to 12 volts and the internal resistance is 0.1 ohm connected to a resistance of 14.9 ohm. Determine the current and potential difference across the resistance and terminal voltage of the source. This is the question. Before solving any problem, we have to study the problem twice or thrice, and we have to know what is the given data, and we have to detect what we have to find. In this problem, the given data is, that is, the source EMF is given as 12 volts, and the internal resistance R is equal to zero point 0.1 ohm, and also the external resistance is given as R is equal to 14.9 ohms. And here we have to find the value of the current, and also we have to find the potential difference across the resistance and the terminal voltage of the source. If we draw a circuit for this problem, it will be like this. The voltage, the EMF applied is 12 volts and the internal resistance is zero point 0.1 ohm, which is given by small r, and the external resistance connected across the source is 14.9 ohms. Here the formula required is that the total resistance is equal to internal resistance plus external resistance, because here the two resistances are connected in series, so the total resistance will be the sum of the two resistances. That's why the total resistance is equal to internal resistance plus external resistance. And also here the formula required is I is equal to E by R, or we can write it as simply V is equal to I product of I and R, where I is the current and R is the resistance. Now let us first find what is the total resistance present in the circuit. Since the two resistances are connected in series, the total resistance will be the sum of the two, that is small r plus capital R, which is nothing but zero point 0.1 plus 14.9. So we get 15 ohms. This 15 ohms is the total resistance present in the circuit. And from the Ohm's law, we know that I is equal to E by R, where I is the current flowing in the circuit, E is the EMF applied to the circuit, and R is the total resistance in the circuit. And we know that the EMF applied is 12 volts and the total resistance in the circuit is 15 ohms. So if we substitute that, we get 12 by 15, that is 0.8 amperes. This is the current flowing in the circuit. Now in this we have to find the potential difference across the resistance. So the potential difference across the resistance can be found by V is equal to I into R, which is nothing but it is the Ohm's law. We know that the current flowing in the circuit is 0.8 amperes, and the external resistance which is connected to the circuit is 14.9 ohms. So the potential difference across the resistance is equal to zero point 0.8 into 14.9, that is 11.92 volts. This is the potential difference across the resistance. Now we have to find the terminal voltage of the source. This terminal voltage can be found by applying a KVL also, or a simple formula. Think about the terminal voltage V is equal to the EMF minus voltage drop. Here the voltage drop in the internal resistance can be found by a simple formula I into R. Okay, if we substitute the value of EMF I, that is current, and resistance, then we get 12 minus zero point 0.8 into 0.1. Okay, then we get 12 minus 0.08. On solving this, we get the answer as 11.92 volts. This is the terminal voltage of the source. Okay, now let us solve the next problem, that is the problem number 5. A direct current of 0.02 amperes is observed to flow through an electric circuit, and how much charge is transferred through a section of the circuit in a time of 20 amperes, 20 minutes. In this problem, the given data is current flowing in the circuit I is equal to 0.02 amperes, and the time t is equal to 20 minutes. We convert that minutes into seconds. that is 1 minute is equal to 60 seconds. So if we convert the 20 minutes into seconds, we get 20 into 60, which is equal to 1200 seconds. And here we have to find the charge. Here the formula required is I is equal to Q by T, where I is the current, Q is the charge, and T is the time. Now let us solve this problem. From this, the charge Q is equal to I into T, where I is given as 0.02 seconds, sorry, 0.02 amperes, and T is given as 1200 seconds. So if we multiply that, we get the charge as 24 coulombs. Now let us solve the next problem, that is problem number 6. This is the last problem. If 80 joules of work is done in moving 16 coulombs of charge from one point B to another point A in an electric field, then what is the potential difference between points A and B? From this problem, the given data is that the work done W is equal to 80 joules, and the charge Q is given as 16 coulombs. And in this, we have to find the potential difference V. Okay, V must be 4. Here, the problem required is V is equal to W by Q, means work done by Q charge. The potential difference V is equal to work done by Q charge, or its unit is coulomb. So V is equal to W by Q. So Now if we substitute the value of W and Q, we get V is equal to 80 by 16. If we solve that, we get the answer as 5 volts. Means this 5 volts is the potential difference V. From this presentation, we have learned about the limitations of Ohm's law, and also we have solved some problems on Ohm's law. Now let us see a small quiz on this presentation. The first question is, Ohm's law is not applicable in all the following cases except option A, electrolyte, option B, arc lamps, option C, insulators, and option D is vacuum tubes. So the answer is insulators. Now let us see the next one, that is ampere second could be the unit of option A, voltage, option B, charge, option C, power, and option D is resistance. Yes, the answer is charge. Charge unit is ampere second. Now let us see some frequently asked questions from this presentation. First question is, what are the limitations of Ohm's law? And the second one is, it's a problem. How much current flows through a 50 ohm resistance when a potential difference of 12 volts is applied across its terminals? Means here resistance is given and voltage is given. We have to find the current. Next, the third problem, the third question, that is a resistance of 2 ohms is connected across a supply of 12 volts which varies in steps of 2 volts from 0 to 12 volts. Calculate the corresponding current for each step of voltage and also draw the graph by assuming voltage on x-axis and current on y-axis. The similar problem we have solved. So by seeing that, we can solve this problem. Okay, thank you very much for listening with patience.